Have you ever looked at your solar panels on, a really cloudy, rainy day and just wished they could still be pulling in power?
Oh, absolutely. It's a common frustration, right? That limitation.
It's been a huge hurdle for renewable energy.
Mm-hmm.
Really restricts where solar can, well, truly thrive.
Mm.
But what if rain wasn't the problem? What if it was actually part of the solution?
Now that's an interesting thought.
Yeah, so today we're diving into your sources on this really exciting innovation. Rain-powered solar technology turns precipitation into a consistent energy source.
That sounds almost too good to be true.
Right, so we'll explore how it works, the impact it could have, and what it means for renewables, particularly using this example of Williston, North Dakota.
Okay, I'm intrigued. Williston's a tough climate.
Exactly. So, okay, let's unpack this.
Mm.
How is this magic happening? What's the core idea here? Pulling power from a raindrop.
Well, what's fascinating is it comes down to something called triboelectric nanogenerators, or TENS for short.
Tendings, okay.
Yeah, think of them like these transparent layers that sit right on top of conventional solar panels, super thin.
Mm-hmm.
And their design is pretty ingenious. They convert the mechanical energy, like the impact, the motion of falling raindrops, directly into electricity.
Wow. So, like friction.
Exactly like friction. It's a bit like the static electricity you get rubbing a balloon, but, engineered to capture energy from rain. Scientists over at Suzhou University in China really pioneered this.
Harnessing static from rain.
Mm.
That's pretty wild. And you're saying these aren't just tiny gains. I saw mentions of bridge array generator designs.
Right. That's where the recent advancements get really interesting.
What makes those so much better? Nearly 5 times the output, apparently.
Yeah, it's about optimizing the contact. These bridge array designs, they structure the tangs in a way that maximizes how each raindrop interacts with the surface. More efficient points of contact, better amplification of that triboelectric effect.
Ah, okay. More bang for your buck, raindrop-wise.
Precisely. Leads to that big jump in output. And importantly, the system's designed to automatically switch. Solar when it's sunny, rain power when it's wet. Seamlessly.
So you're always optimizing whatever the weather.
You got it.
Yep.
No need to flip a switch.
Okay, let's bring this down to earth. Williston, North Dakota. You mentioned the tough climate.
Yeah, Williston is a perfect test case, really. It presents a unique challenge. They get decent sun, average about 4.7 hours daily, peaks in summer, but they also get year-round precipitation, rain, snow, and the winters are brutal. Temperatures can plummet to -40 Fahrenheit, sometimes even colder with wind chill.
-40, right?
Yeah.
So traditional solar panels just hit a wall in those conditions.
Yeah.
Especially with rain or snow cover.
They absolutely struggle. Production drops way off. So this tank technology isn't just a minor boost in a place like Williston.
It sounds like it fundamentally changes the economics, makes solar potentially viable where it just wasn't consistently before.
Yeah. That's exactly the insight. We're talking about making clean energy more predictable financially. For a typical home there, maybe a 6-kilowatt system, the initial cost, let's say after the federal tax credit, is around $21,000.
Okay.
That system could generate, say, 8,000 kilowatts from the sun annually, but then add another 800 to 1,200 kilowatts just from the rain.
Just from rain. Wow.
Yeah. So your annual savings might be $1,200 to $1,500. Now, traditional solar might take 13 years to pay back there. With the rain power added in, you shorten that payback period down to maybe 11 or 12 years. Lifetime savings, over $25,000 on average. It adds that all-weather reliability.
Those numbers are really compelling. Makes a huge difference in that kind of climate. But okay, practical side. Those extreme winters, they still pose challenges, right? Even with this tech.
Oh, definitely. You can't ignore physics. Snow buildup is still a thing. Panels might need clearing sometimes, just like regular ones. And the battery storage systems, they need serious insulation, everything. All the components, they have to be rated to handle temperatures well below that -40 mark to be reliable.
Makes sense. Need robust gear.
But, despite those challenges, North Dakota is actually 13th in the U.S. for available sun hours. There's potential there.
Interesting.
And the infrastructure is growing. Local installers, supportive grid policies. This tech lets them use all their weather resources more effectively. Rain or shine. Makes the whole energy system potentially more resilient.
So it's really moving beyond just a concept. Rain-powered solar is emerging as a genuinely innovative way to maximize renewables, turning bad weather into an asset. It kind of flips the script.
It really does. And, this raises a bigger question for the future.
Yeah.
As manufacturing scales up and hopefully the costs come down, how could these hybrid systems really change the global energy picture, making clean energy truly reliable year-round, whether it's sunny or pouring rain? It's a potential shift from fair weather renewables to genuine all-weather power.